Okay, move on. Let's wait for 5 minutes. Email, please like the video and get me to the channel, please. Now let me check my mic. Mic test 1 2 3 1 2 3. Okay, let's start the video. So, this moment is not a polished tutorial for update seekers. This is my personal learning journey. If you're interested, you can join. But to be honest, this will be very boring. Thank you very much. So let me start. Yesterday we saw up to the macro. Macro is not a variable; it's a where which is defined using the hash defined preprocessor directory, which is replaced by its replacement hash during the reprocessing phase of the program translation. like a find and replace, you can say. So we saw object like functions, object like macro, and functions like macro, and the use of macro in dev environment. So when you're developing, how can you use the macro? So that's what we saw actually. So today I will be starting with recursion. So chapter 23, recursion. So first, let me go through my notebook. Let me go through my notebook, and later we will discuss it. Okay, let's discuss on recursion. So let's write about what is recursion. There's nothing but function call itself repeatedly till the given condition is satisfied to solve a problem. The function calls itself repeatedly till the given condition is satisfied to problem. So it can be either directly. So what does it mean? Means x. So function calls uh, f calls. So let's write x calls x. So itself it is calling, or cyclically. Cyclically in a chain. So it is like x calls y and y calls x in cyclic. So this is also recursion on the. So generally loops are solved down to top. So this is generally only, okay, not a fixed rule. Recursion solves the problem top to down. So let's see two conditions. For a problem to be written in recursive. First one is it should be possible to expressible in recursive form. And stopping condition must be included. So let's see some examples of recursion. First one is factorial of number n. Next one is GCD of m comma n. Third one is Fibonacci series. So let's see factorial of n example. So factorial n can be represented like this. This is what we call factorial of n. So the formula is multiply 1 into 2 into 3 up to n. So it's like multiplying first 10 natural numbers, like that you can say. So if I say 3 factorial, that will be 1 into 2 into 3, which gives 6. If I say 5 factorial, that will be 1 into 2 into 2 into 3 into 4 into 5. So that will be 120. So n factorial is nothing but we can say n minus 1 factorial or n. So we can represent 5 factorial with 4 factorial and 5, right? So up to here, this is a 4 factorial now. So 4 factorial into n. So this can be, and if we solve this, uh, then just multiplying with n is enough. So this is again same formula using happening. So you can write like function f of n equal to n factorial. Let's say, so I can write like this. So f of n is equal to f of n minus 1 factorial into n. So now replace f of f of n minus 1 with the formula. So you can write f of n minus 1 equal to f of n minus 2 n minus 1. With the help of first statement. So first statement is nothing but this one. So now if we replace f of n equal to f of n minus, let's say small n, so n minus 2 into n minus 1 or n. So again expand, so again expand the f of n minus 2. So now f of n will be f of n minus 3 into n minus 2, okay, and from previous n minus 1 into n. So we can write like this up to, so when can we stop here? So when f of n, so when it comes up to 1, f of 1, so it will be 2, it will be 3, it will be 4, drag it up to n minus 1 star n. So we can say base condition. So f of 1 is nothing but 1 factorial, which is equal to 1. So f of n equal to f of n, sorry, 1 star 2 star 3 4 5 n minus 1 up to star n. So this is what, so now we can see we are dividing into problem into sub problem. So when I calculate for f of 1, so I will be first calculating for f of n minus. Again we are dividing into f of n minus. So we are writing in a recursive form. We are calling the same function itself. So first point is agreed upon the two conditions and the stopping condition. So what is the stopping condition here? When it becomes 1, so f of 1 is equal to 1 factor is equal to 1. So this is the stopping condition. Now I think no need to write. Now let's write the function here. So let's write int x is equal to, I want 5 factorial. Okay. So printf and it returns an integer. So let's write our factorial function. Okay. Calling with text. So let's declare here. So we'll return, we'll declare here the function prototype. So factorial of int x. Okay. Now we'll write the logic. So what we do? First we have to return. So we can so this is the f of x. So now I can write f of x minus 1, right? And star x. So this is what I can write. So f of x is nothing but calling factorial of x minus 1. So 5, first we will calculate for 4, and then we will calculate for 3, then we will calculate for 2, then we will, for calculation of 1 it's nothing, it's a base condition, it's stopping condition. So we have to write. So let's say the if condition x equal to 1. Okay, so return 1. So now let's run, it should give the value 120. You will see 120. So if it is 6, 120 to 6, it will be 720. If it is a 10, you can see it is coming for some big value. So if it is 1, let's check for base case, it's coming. Let's see for 0, yeah, it is not printing. So for 0, I have to write something, right? So 0 factorial is also 1. Is equal to 0, return x, because this will be only going inside if x is equal to 1 or x is equal to 0. So return 1. So sorry, it is return 1, sorry. So now let's do, it is doing 1. So the base condition you can give, you can give up x is equal to 0. That is better. So let's write there. One is good, one only, right? This is a formula I follow. So let's write according to the formula only. So there will be no confusion. Now it is given. So this is an example of a recursion factorial. So now let's understand mechanism a bit. I don't want to go in more sums recursion because recursion is useful, like not useful. You can more practice in data structures and algorithms than programming in C. So and I don't want to do data structure algorithms in C because C is not that much easy to write the code. Uh, for in C++, we will have STL, so stash, some containers, standardized containers. So it's like a predefined inbuilt function. So stack I can use inbuilt. In C, I can't use the inbuilt stack function. I have to write from A to Z. So priority queue, set, hashing. This can be done in inbuilt in C++, but not in C. So that's why for data structures and algorithms, so if you want to practice competitive coding, it's better to do in C++ or Python. So let's see mechanism of execution. So I wrote like a formula, but how it will be happening inside is the key, right? So let's ask ChatGPT also. Explain mechanism of execution of recursion. So let's read this document which is given by ChatGPT. So let's what is the recursion? So here a function calls itself. So here we are calling what is this is we're calling the function up to return 0. We are printing the value. So we can do this for loop also. For loop which is a down to bottom. So we will start with 0 and we'll go to the 3. That is the down to bottom loops. Recursion is the top to bottom. So we'll write the 3 and we'll go down up to the 0 and then we'll print. So you can see output 3 to 1. So here function 3 calls function 2, which calls function 1, which calls function 0. So what actually happens in memory? This is important part. When main calls function 3, a stack frame for the function 3 is created. So like this you can say a stack is created. So the function 3 function starts executing. So it is just before this function, right, before calling itself. So that's why this was printed and then it will go at this point. If you reverse it now, first it will not print, it will go to the function n minus 1. So let me show you that one also. So let me put down. So it will print 1, 2, 3. You can see, right, 1, 2, 3. So what will happen? I will tell you in brief time. So what will happen? You will see what actually happens in memory. Will see. So main calls, right? So main is a stack. Stack is nothing but it's a data structure which stores the data in last in first out form. So whatever will be inserted at last, it will go first. So function 3 got in, right? So it will be going first from this stack. So, so function 3 is not executed, just calling itself another function. So it will be going above the function 2 will be no come. It simply passed. So it is waiting function 2 finish. So the function 2 executes print, and then it will be the function 1 is started. So again it is passed, and function 1 is pushed to the stack. So when function 1 happened, function 0, again function was passed and function 0, but function 0 is written, right? So this is the starting condition. So we didn't call another function. So we returned the function. So function 0 is now completed. The function will execute. So there is no another line, right? So it will not show you, but it is over. It will be completed. So you can see function returns, then function returns. Now function 2 assumes it has nothing to do with tomorrow. So returns. So up to main it will come. So this is a complete picture. Stage 1 going down. Entry function to function 0. The stack grows. And the stopping condition coming, it will come in reverse order. It's like a spring coming back up. So because every function calls needs to remember its own shape. So when I'm leaving function 3 to function 2, right? So it has to remember where I called and stopped, right? So it is like where I am at the function 3, it will store it in the stack, and it will go to the function 2 fresh. So when function 3 coming, the down phase, function 0, that is this function 3, and again when it comes, it will execute where it function 2 is called, right? So from down it will execute the. So this is the example I'm talking right here. So if you do this one, okay, now let's see the fun. So first at this time 3 is executed, okay, and then function 2 is called, so 2 is executed, then 1 is called, so and then 0 is called, 0 is written. So at the function 1, uh, we are at here, okay. So we executed F0 and we are coming back. So F1 it will start from here. So returning 1. You can see here, right? Returning 1. Because F1 and then F2 also executes here. So returning 2 and then 3. So it is like a string. So I compress 2, 3 to 1. And then when I release 1, 2, 3. So what is inside the stack? So let's see how it is inside the stack. These are temporary show. So I think let's better draw this one. Okay. So So let me use paint here. Okay. So this is f of 3, right? So let's so first I call it f of 3. So what will happen? It will check if f of n is equal to 0. No, it is not. So it will be executing this one. So here print will happen. Okay. So before going into f of 2, okay. So before going to f of 2, what will be we are doing? So 13 line we check, 14th line, 13 and 14 are skipped. This one is skipped. And then 16th line we printed. So 3 is printed. So and then what? So before going to call so f of 2 again it's calling. So this one n will be 2. So again before going to f of 1, so what does it do? Let's check. So 13, 14 it will be skipped. Okay. And 16 got printed. So 2 prints. So now what will happen? Hmm, let's take this as big. So up to 16th line, f of 2 print, f of 2 executed, and f of 3 also up to 16th line it is good because the 17th line it's calling the function. So it should go into that function, right? So let's see the stack also here. So first it will be main. Okay. And then what we are doing? We are doing f of 3, right? So what the definition is saying? So when you are calling a function, so when f of 3 is called, then we are putting into stack. Not f of 2 is called, then we are not putting f of 3. Okay. So when f of 3 is called, then only we are putting in stack. Okay. So at here it will be f of 2. And it's called. So now f of 1 is called. So this is f of 1. So f of 3, f of 2 main are not executed. Okay, not fully executed. They just passed and they are giving time for f of 1 function to be completed. This recursive function. So so what will happen now? F of will check 13, 14 line. So both are not satisfying, right? So then it is print system. So one is printed. So now it is f of 0. So f of 0 13 and 14 are satisfied. So return. So it's a void return. So it will go here. So now here executes 18th line. So in the stack when it is called up of 0, right? So when it is returned is called, so we'll remove from the stack. So now at the top, let this arrow mark be the top of the stack. So now F1. So F1 where it is there, it is at the 17th line. So it will now execute the 18th line. So what will be printed? 1 will be printed. So execute 18th line. So 1 prints. And then we didn't write any return statement, but implicitly it will convert. So anyway, it is void on the right. So it is completed. So it will be out of the stack. You can see it. What are we putting inside the stack at last? That is going first. So this is the top of the stack. We change it to f of 2. Now again is coming here. F of 2 is printed. 2 value 18th line it executes. So it is completed. So f of 3. And then in the main function. Nothing there inside the main function. So this one also completed. So this is what is happening. In the sound line, in the sound point, that's what the chat is saying. So now let's learn what is inside a stack. Each call gets its own activation record or page. This is nothing different. Like stack frame is nothing but inside stack giving some memory. For example, a function of it as its one and is equal to 3 and the return information. Well, f of 2 has completely separate n is equal to and return. And sum of 1 will be n is equal to 1 and return. Also, although they are executing same function, each has its own copy of local variable. So, one thing which is there are the same function, but each just stack frame has its own copy of local variable. So conceptually, frame n is equal to 1, n is equal to 2, n is equal to 3 is one of the important things to be understood. Very useful mental model. Whenever you see function inside a function, imagine pass the current function here, create a new step, execute the new function, and it returns come back exactly where I passed. So that's what I'm telling. So when execution happening here, and you're returning, you're executing from the line hash lines. Okay, come back exactly where I passed. So 17 is completed. So now go to the 85. Now for recursion, pass f1, create f of n minus 1, pass f n minus 2, base case return to resume previous calls, return. So that's what it is doing. Each recursive call creates a new stack frame. The previous functions is passed where the new call executes. The base case stops further recursive calls. After reaching the base call, function returns in reverse order. So let's copy this, paste it in our. It is like a spring. compression, and expansion. So let us decode what happens inside the function in very deep. Okay. So it explained in theoretical way. So let's ask what happens in stack during recursion, uh, giving a depth. So let's learn very deep here. So what we learned before is a theoretical. Now we will go into somewhat deep. Okay. What happens to the call stack at every function and return? So let's use one simple example to trace the stack carefully. First understand what the stack is doing. So call stack is a region, or let's understand call stack is a region of memory used by a running program to keep track of the activation function calls. So it is nothing but a region of memory. So region of memory means a RAM be taking some place. So this one is used by running program. So why it is using means to keep the track of the active function calls. So when we really call it f3, so it will be pushing into the stack. So when a function is called, the system creates a stack frame. It is also called activation for the call. So for that particular function. So in call stack, some space is allocated to a particular function. So a stack frame conceptually contains information such as local variable, parameters, return information, stored mission state registers, and other compiler or runtime data. So the exact contains layouts or the implementation, but this is the usual conception one. The implementation depends how the compiler wants to do it. So we'll not go that much into the implementation dependently, but you can say up to this four are very common. So local variable. So n is equal to is different, and f of 3 is called. So this is the local variables and the parameters. In parameters is nothing but functions index x is there, right? So that x return information. So let us see what does it mean. So saved mission state and registries of this one I too don't know what it means. So let's see. Consider this recursive function. Again, we took the same function here. Main is called, so every program starts with, so C structures are nothing but uh, functions only. So one of the common function like must and should be, which is main function. So main function is the starting, and the program starts, it executes with main. So main is also a function, so main will be thrown inside the stack. So now f of 3 is called. So in main f of 3 is called. Okay, something important happens. This current execution must be running now because after f3 finishes, the program has to know where should I continue executing inside main. Right, so it should remember. So So a stack frame for F3 is created. So f of 3 is pushed, and here we saved the required information. Once f of 3 is executed and completed and thrown out of the stack, we have to execute. We have to resume the main after that when like after the function is called. So we have to execute down this after this function call, right? So here nothing is there. So function 3 has information related with particular invocation. For example, now n is equal to 3. This is the local variable. Return information, saved execution state. Let's see. I think I hope down below what does it this mean. So function 3. So function 3 starts executing. Okay. N is equal to 3. Return n is equal to 3. Is not 0. We have to return. So it is nothing. So then print of will do. 3 is printed on the screen. Then executes. So we are again calling the function. So it should be thrown inside the stack. So f of 3 will be passed and f of 2 will be continued. No, no. F of 3 is passed. So f of 2 is pushed. Pass currently executing. Notice something. There are two instances of same function. So they are not same invocation. There are two function calls with separate stack frames. Each call as its own n. So this is extremely important. So we have local variables n with different values. So don't share the same n. It should be that is where recursion works. Okay. Same f of 1. So this one is passed and this one is executed. Then f of 3, f of 0. So f of 0 base case it is following rate. So return statement. So now something happens to this one. So the function 0 stack frame is popped consecutively before return. After return we throw the f of 0. Main it goes back immediately after the function. So f of 1 it executes the execution returns here. So I think this is the return information. So how to come back? Now same thing, resumes and all these things are just examples. Pushing or calling, then popping and returning. This is what we saw. So if you give more than the uh, stack, then stack may run out of the value space, and this is called stack over. Best example is we didn't write any base condition, right? So this is not a recursion, but it will recursively infinitely will be stack growing and stack will be crash. Important distinction function versus function call. Distinction, suppose you have void function, there is only one function, but every function then recursively it has function invocation. Question gets its own Let me read this one. What exactly does written do? Consider f of n minus 1 written in. So when f of n minus 1 is called, the function is passed. For example, f of 3, f of 2 pass here. So when f of 2 usually returns the problem, I need to resume a function 3 after the call to function 2. The return mechanism uses saved execution information to resume the caller. So at the machine level, this involves mechanisms such as return address and the saved process. So exact details explain. So then at the machine level, this involves mechanisms such as return address and saved process state. Exact details depending on CPR ticket and calling convention. I will be continuing. Let's wait to convention. Let's continue this recursion and we'll take a break. Okay. Stack stores the information associated with the particular invocation of that function. It does not store the function, but it stores what required for the particular invocation. Okay, so code is shared, but stack frames are separate. So that's the important concept. So the complete mental model. There is a minimum conceptuality you can use for statement, even though the exact load is decided by the CPU and CPU and compiler, calling convention, optimized level, etc. So the best way to understand statement contains information needed to keep one particular function invocation alive and the initial return to its caller correctly. So let's go deep into what it let's see what is function now invocation. So this is the function definition. Okay, so when we execute f of 5, we create one invocation function. So that invocation has its own x is equal to 5 and a is equal to 10. Yes, it has its own x and the 10. Okay. So it needs information that allows the program to eventually return to main. Conceptually, function is stack frame. So invocation nothing but calling a function. What is the stack frame need to remember? Thinking about what happens when main states step of right. So the parser is currently executing main. It needs to start executing fun. Give fun its argument file. Give fun function from there to store its local variable. Remember where main should contain after fun function. So, so in function stack frame, not in main. In function stack frame, we will remember where main should contain after fun function. So that is called return. These are whatever information from the caller must arrive while fun executes. Reserve what information from the caller okay must survive while fun executes eventually restore the necessary statement then function. So I didn't understand these 2 points. So therefore conceptually this frame contains several categories of information. So return information, saved caller or mission state. Sorry for a pause. Let me continue. So I didn't get these 2 points. So preserve other information from the caller must survive while fun executes. Eventually restore the necessary state when function returns. So let's see this diagram. So return information is nothing but remember where main should continue after. Okay, let's see. So return information, saved caller state, parameters or arguments related, local variables, temporary storage. So temporary compiler generated storage, other implementation specific to information. So let us see what each one follows. So these aren't guaranteed to appear in this order. May not usually feasibility in the stack. And a modern optimization program. Now let's understand each one. So conceptually you'll understand. Return information. So suppose when my main function calls f of 3, the processor needs to know after main finishes which should where should execution continue? So this one or above one or after two lines, so it has some conditions, right? So it should execute at print hello. So conceptually the function invocation needs a return address. So return address represents the locations in the caller's code where the execution should resume. So return information is nothing but caller, the main called by calls the fun, right? So after this execution, processor should know, right, where it should execute from. So this is the return address. Return information. Uh, so this will be stored in function, not in main. Okay, so not a return value where execution should continue. So this will be stored in this address of this location. Print hello, print of address of location will be stored in address means instruction address will be stored in return value, return address, return information in function stack frame, function by stack frame, parameters and arguments. So x and y, this function is to access to these values. Conceptually, the invocation state includes function 10, x equal to 10 and y equal to 10. So that's what parameters and arguments. But here we need to import modern clarification. So they don't necessarily have to physically reside inside the stack. Depending on the calling convention, arguments might initially be conceptually registers. So in registers it can be, for example, a CPU might effectively do something conceptually like registers. So in RAM, these registers will be there. Uh, so in registers we can store these variable values, but registers are limited. Depends upon RAM. Okay, so instead of stack exc, stack y, if the function needs to preserve them or take their address, the computer might later store them somewhere else. So what does it mean? What does it mean? So I didn't get this point. The last so parameters do need to occupy physically stack memory. I gave the prompt. Before that, we will complete this one local variables. So this is the local variables and this is the parameters. Yes. So for an invocation, we conceptually have. So the invocation needs storage for its local variables. Conceptually, okay, like this will do, but this is also important only. Uh, different values for the local variable. Even this is a parameter, x is parameter. Once inside this function will be a local variable. This is a parameter, so both are different. So here x will be stored, the value will be stored in stack for sure. You can see it, n is equal to x is equal to 30, n is equal to x is 20, n is equal to 1, x is 10. So what they wrote, x is equal to n into star into 10. So at f of 3, x will be what? So x will be 30, at the 2, x will be 20. So this is a local variable. So this x does not with this x. Okay, so that's what they are telling. Calling where is given. That's all. So next one is saved mission state or registers. Now we get closer to how an actual computer works. So let's see what is that mean. So we'll be coming at some point. So that one I give the prompt right. Parameters by the don't talk by the stack memory. So let's see what does it mean. So when you call function f 10 comma 20, the function needs to know x is equal to 10 and y is equal. The argument must somehow be made available to function. So for learning C, you think function location type them x is equal to 10. But there is one technical detail. The C language does not say that x and y must physically be stored in stack. The compiler is free to use CPU register. Instead of using stack memory, they are architecting like they architecture such that you store in CPU registers instead. Why did I mention registers? Imagine two possible implementations. A simplified model, good for learning. Okay, so if it is a CPU register means it will store the register value, not the variable value. So that's what. So what you remember for your concatenation of recursion statements, remember this: when a function is invoked, its parameters and local variables are part of the invocation state. The stack frame is the conceptual place associated with the state. So that is what they are telling. Its implementation strict it is. That's how like, register wise you can store it content variable that is your wish. I mean implementation. On analogy, imagine you're giving some task function 10 comma 10. You need to give them 10 comma 20. You can give them the numbers right on the paper stack. Spoken directly register. So store somewhere else, other number. So the important thing that is function looks for actually the values. The method used to deliver them is an implementation. So how we when this function comes back, right? How I mean, yeah, how it is received these values or accessing values, so its implementation detail. Okay, I got it. Now let's go to the sound point. saved machine states and registers. Now we suppose get closer to how an actual computer works. The CPU has registers. For example, CPU has reduced the content, current stack location, current instruction location, general purpose values, etc. Suppose main is using some register containing value that it still needs. The main function call. Okay. The function we want to use the same register because registers are not infinite. There will be 32 like that. It is there. So sometimes the register should be used for this function. We can't destroy the value, right? Therefore, depending on the calling convention, some registers values may need to be saved and restored. So it will save before calling function. So main it will reserve r is equal to 100 in this r. So register r is equal to 500. Before returning the PS value, may need to restore the register r is equal. So information about saved state can be registered with the stack string temporary storage. So the compiler may need temporary storage like evaluating. For example, in result, the compiler has to evaluate pieces of the circuit. Depending on the generated machine code, temporary values may be held in register, stack memory, and other like parameters. So a stack frame can have space for temporary values needed during execution. Uh, so let's say result is like will be used at down, but the middle one function is called. So this is the temporary storage. So result will be stored some value somewhere at the registers how it is pointing. Okay, so space for local variables and other local updates. There are local updates and other automatic storage duration. Constantly storage need be part of stack sprint. Again, may remember the compiler can operate in civil and some objects may leave registers or not stored at all. They have to be remembered. This is required for calling another function. So as per the training, what outgoing garments, temporary variables, other model price and other local objects. So that depends on API independent. Frame pointer, stack pointer. So these are registers, not necessarily sitting inside the frame. Stack pointer points. These are registers. Okay. So the stack pointer points to location shared with the current stack. Okay. Simply now remember like a pointer conceptually. When registers coming, we can understand this one. The frame pointer may use frame pointer to provide a stable reference for accessing the current communication data. They use a frame pointer to provide a stable reference point for accessing the current invocation data. So it is like pointing to a stack frame inside it. Yeah, so frame pointer will be not used. You can use it like a formula, stack pointer plus other mechanism. So don't memorize every stack as frame pointer. That's not universal. So value does not, but CPU register will hold when written. So we'll use that register value. So minimum conceptually for shading, want to clear, I want to carry this literal information. Where should execution resume? Parameters and invocation state. What argument does this function have? Local variables and the objects. What local state does this invocation of? Saved or missing? What must be preserved so that caller can continue correctly? So temporary and compiler data. What temporary storage needed? Other specific implementation. 1, 2, 3, 4, 5, 6. Written information, parameters, local variables, saved machine state, saved caller or machine state, temporary data, and other specific implementation. So now let's send everything to recursion. Take function. Okay, that's equal to 10, n into 10, n is equal to 0. So call f of 3. So what it will say, n is equal to 3, x is equal to 30, return on save state. Then it is called f of 2. One of 3 stays alive because that is finished. Instead of like this, it will be CPU registers. So this is nothing but again it is showing, but don't like this one. So let's complete this one and then we'll write the continue the form. Giving again the same below and above. No, it's not being properly. Then what we have saved our mission state. Okay, so at f(3) will be here the main values. So this one, so R1 is there on register. At main it is used R1 is equal to 500. So now I will save this 500 here. But now fun will overwrite R1. So when this one is completed, when it goes outside of the stack, so it will give R1 as 500 only if comparing it. Yeah, correct only. Okay, if parameter one it took. Okay, yeah, let's now ask. Yeah, this much is enough. Let's let's remove this all and add this one. So let's take the call stack definition, which is like a program memory which stores invocation values, right? Function invocation information. So this is what we learned. We learned very deeply on how the recursion stack maintains the recursion is happening conceptually. So now let's take a break of 15 minutes. Okay. Okay, let's start with the other chapter. So let's start with another chapter. Chapter number is 24. Let's go into structures. So structures are opposite of arrays. So in arrays you can store same data type elements, right? So in structure you can store different data elements, data type elements. So let's take a formal definition. The structure is data type that allows you group related variables of different types into a single unit. So let's take this definition. So it is a convenient and tool for handling a group of logically related data items. So the individual elements in a structure at this point also arrays only store particular data type. Elements can be stored, but for different data types, leave a structure and in union is. So let's see structure only for this part. So let's see the syntax. So it will be struct. It's a keyword. Okay. Tag, which is a name you can give, like a variable or we give index. So like you can give any name. All right. Number one. Number two. Two member m. I will tell what is member n also. And close it curly braces and with semicolon. So semicolon is there. So the individual elements in structure are called numbers. These are the different data types you can use. You can write number one as int x and this one as float x, float y. So So what these numbers can be? So numbers can be variable, array, pointer, and other structure. So nested structures also can be possible. So let's write struct. So struct keyword you use, and let's write it in student info. Okay, open the curly braces and insert semicolon. State character array or string. I think string is better. And int age, and what can we give? I think this will be name and age will take. Okay, and that's all. So if I say student one, okay, student one dot, you can access this numbers with using dot operator. So name is equal to, let's say, John, and the student one dot age is equal to 10. Let's see if it is running or not. Student one is known. So sorry, student info, right? Let's make it student. Now let's check why it is giving error. The error is because name is an error, and see, you cannot assign a string to an array using after the array has been declared. Okay, so the structure, this is an important point. Name is an array capable of storing a string, but id is invalid is an array. So C does not allow array assignment. Yeah, I think this one is alright. Like here we can give at the declaration, but you can't give here. So string literal is not something you can directly listen to. So they have to do string copy. Okay, got it. This is what I'm. So like this you can do, or like this. So like this is what I'm doing. Just take and type in strings. So let's write here. For note. So you can't do like this. So let's string copy. CPY student one dot name. So this is the destination and source is from string literal. Now let's run. So we have to declare that we have to include header file string. So now it will run. You can see right it is giving. So we can do two types. So struct student, take student two. Okay. So and at the here I can give the initialization. So John, Martin. Let's see, this is John 2. Well, now let's print the objects. Hmm? Oh, why it is giving chains here? How to leave the numbers in a struct? So this is a array actually. So we can't loop numbers uh, automatically. So let's print it. Percentages, it's a string. So that's it. Student one dot name. Student one name is babies. Regulate dear. Now student two name is student to age. Now let's print. You can hear it. It is printing beautifully. So another way you can uh, define uh, uh, with the structure student variable you can write here. So structure so another way I want to say like structure struct student, like where you can write after between these two. I'll write student 3. I will access here student 3 struct student, sorry, not struct, string copy student 3 dot name John 3, and then student 3 dot age is equal to 11. Let's put this one as 7, this one is 12. Let's print out this one. Yeah, I can see it. So this one also possible. So let's define. So let's try here also. You can ensure directly here or not. Yeah, you can do like this also. So let's take this one. Now let's declaring a variable in a structure. So let's check the syntax. First one is struct tag number 1. Let me copy this one. And you can define the variable here. So variable 1 comma variable 2 variable 3. You can initialize a variable here also. So what does it means like this? Or finish the struct keyword, set the tag and variable. Both are same. Okay. So now we will see accessing the variable, accessing the structure numbers. You can write like variable dot dot member 1. So I gave the example here. Like this pointer number superstructure C does not loop mechanism or automatically visiting. If you want to uh, print, let's say how int age and int x in a structure, and you want to print this both, then you have to write two printf statements. So there is no looping here. Okay, so that is what this sentence means. So a structure variable can be directly assigned to another structure variable of the same type. Sorry for the pause. Now let me write in what is the statement means. Now let's take student 3 dot age is equal to student 1 dot age. Okay, so now student 3 age should be 10. Let's see why it is giving error. Okay, it is here. I can see right student 3 age is become 10. Let's not take 2 here because this is the identifier and this identifier is same. Let's take struct. Let's give the same value. Let's give value 14 here. Okay, make it 4 here. Now let's see. Yeah, it's giving. Now let's remove this one. Now let's see. Yeah, it is still giving. So from this, so the condition is structure variable of the same type. Both numbers should be same. Even the tags can be different. Can be different. That's a strategy also to confirm the statement. Okay, this one is like making student is equal to student. Student to, yeah, now we will change it to 11. So that is what we saw. So arrays of structures like definition, your variable can be so struct student student list of 3. You can write like this. This is called array of structures. So here the variable is a array and the data type is struct like this. Arrays of structure in C. So it's a collection of structure variables stored at contiguous memory location where each element of array is the individual structure instance. Just like this. So it's a collection of structure variables. So structure variable, 3 variables you can say, stored at contiguous memory location where each element of the array is an individual. So each element, the class from 0, class from 1, class from 2 is a each variable which is stored at contiguous location, that is called array of structure. So, so class from 0 is an individual structure, class from 1 is individual structure. Now let's continue. Type definition. Let's see what is type definition. Is existing is used to given existing data. Existing data type, other name. Existing new name. So index number. So existing type, other name for int. Okay. Essentially the same as index is equal to 10. Okay. So type def does not create a new data type. It only creates another name of for an existing type. Okay. This is good. So I think this can be used in structures. You have to write like this structure string. If I write a type definition, I can use this variable accessing with as one. So this is another way of reading of variable with using a variable of a structure. So let it go down. So you can write like this. So instead of writing struct type one, you can use type C is a keyword used to create an alias or a string. That's almost structure type def alias for struct student. Okay, this is not a variable, right? This is the syntax. This is the existing and this will be the replacement. Okay. So syntax will be, let's take the syntax, existing type and then union. So now let's write to this one. Okay. So type the struct student. Yeah, you can see it. This is type def, right? Type definition. Yeah, type to definition. You can see it. This is initializing, so it is giving comment. So this is not a variable thing. This is a replacement. Now let's uh, let's remove this one. Instead of writing like this, now let's write student 3, student 3, student 1. Now let's run. So it should not give an error. So type the structure and retake it. So here we can take this example. So this is the easy one. Let's ask this question. Structures to be outside of the main function. Right. So it doesn't need to be outside. You can define inside also. So that locally up to in this boundaries only this is applicable. So there is no need. That's so if I write a function using this student tag uh, structure student variable as one, so then I have to write functions, right? So it is better to write outside of it. So now So now, so this type def stuff can be passed to the parameters in a function. So like void fun name student A comma student B. Okay, so write your code or and returning in the structure also can be possible. So student fun name student A comma student A comma student B return B. So let's try like this. So let's define the function. So without writing type definition and one with type definition will write. So let's say for student here, struct to student int name and int age. Okay, so let's we'll take struct to stud. Let's define type define struct to stud. Okay, int name comma int age. Int age with what we will call, let's say person this one. Let's be person. So now let's let's start with the function that will add age. Okay, so compare ages of student and return and return greater student structure. So let's say now the structure student the return type. Sorry guys, I just took a small break. So now let's write a function com compare age for students. So this will be, again we have to write struct student one struct student s2. So if s1 dot is greater than s2 dot is, return s1. If it is equal, then return s2. Equal or s2 is greater. So let's compare. Let's take struct student student. What we can write with the name stud1 student1 is equal to, let's initialize John here 10 and struct. Let's take full copy this one and let's write here John with another 14. This is the student 2. Let's write printf statement percentage d percentage s student name is percentages and his age is, let's give John 2 here. This percentage d. So let's call that student higher age higher age student is equal to, let's write compare age stud and let's give student 1 student 2. So higher using start name is the first percentages and the higher age student dot age. So now let us see what it is taking. This one type definition should be like this. So for a structure, how we write type definition like this one, right? Oh, sorry, I mean this one here. Initialization should be done. Sorry, not initialization. Semicolon should be in it. Sorry, this is the character, right? Character name of 100. So you can see it. John 2 is coming as expected. So now let's see with the type definition. So you can write person here and we'll write same thing, but we have to change struct student to person. And comparing person, not students. So let's take uh, person 1 is equal to John, and the first, let's copy the above one. Let's set John 2 and with age 14, and for some, let's take this whole thing. Okay, so higher age person, where we have to pass function is compare age person and person 1 with and their person 2. So here higher age person. So 2 times John 2 14, this statement should be printed. Let's see what is happening. Okay, this is again integer, so that's character name 100, and the redefinition is happening. So okay, so this is an error. Compare age invalid initializer. What is happening? Oh, sorry, this one is the problem. So return types are not matching. You can see it. Let me put slash in. You can see 2 times it is. This is how we can write. So let's copy this whole code and paste it in our notes. So type definition will make the work easier. So that's what I understood. So today I will stop the live. It's almost 3 hours. I started using. So next live, we'll be discussing pointers, and then pointers and structures, dynamic allocation and file, and lastly file handling. So for this, we'll write and complete the handwritten notebook C, and then we'll start test books. Thank you, everyone, for participating in the live. So please like the video and subscribe to my channel. Thank you so much.